Our next speaker is Alex Paxton. Alex Paxton is a professor at the University of Connecticut. Her work is on interpersonal dynamics and the way that we change and we change others in our interactions on a moment-to-moment basis. Today she'll be talking to us about communities focused on data and what GitHub can tell us.
Wonderful. Hold on just a second. Excellent. Yes, fantastic. Thank you so much for your help. Hi everyone. I am delighted to be a part of this. Thanks to the organizers and everyone helping this happen. This has been a really great day so far, and I'm excited to talk to you about some work that I've been doing that's kind of less statistical and more methodological. Oh no, I just messed it up. I'm so sorry. So thinking about how. Thank you. You. It's not? Okay, all right, great. So it's kind of more methodological than statistical for the set of things that are happening today. So what I'm interested in is fundamentally looking at naturally occurring data as one of the ways that we can leverage this kind of new frontier of data with these goals of improving our understanding of human behavior, cognition, and emotion. And so when we think of naturally occurring data, there have been some great examples that folks have already talked about both in the sessions yesterday and in the poster sessions yesterday. It's this idea that these are data that aren't necessarily created for scientific purposes, but they are repurposed to answer scientific questions. And so they give us this beautiful window into real-world dynamics in a way that we can see how these behaviors unfold fully in the real world. And there are a ton of different examples of what this looks like, whether you're trying to understand human behavior through aggregating Google Trends data and understanding how behavioral epigenetic epidemiology spreads, all the way to understanding how people interact with one another on video games, or even, as we saw with Bruce Hoffman stuff, try to learn a second language through video games. But through all of these, we can kind of see these data not as being kind of fully formed data that just spring into existence out of nowhere, but instead they're digital traces that we leave behind as we engage with other people, with other environments, so we can reconstruct the way that people's cognition, behavior, and emotion unfolds in these different contexts. And while there have been a whole bunch of different amazing ways that this has been done, I'm going to focus on one community that I'm really excited to be working with my collaborators to understand GitHub. And GitHub, if you're not aware what GitHub is, it's a community of software engineers and software developers from a whole variety of different areas that people are getting together and able to collaboratively develop a whole variety of code projects across languages. And as someone who's fundamentally interested in communication and communication dynamics, it's kind of this beautiful encapsulation of community development because it's an almost exclusively online community, which means when we're trying to understand how a community is formed, maintains itself, and develops and is healthy or unhealthy over time, then we can look to the traces that they leave behind in their communication on GitHub to understand how these communities are forming. And so one of the reasons why this particular team, my collaborators and I got together, is because of our interest, not just academically in understanding communication and communities, but also in my other collaborators' interest in open source software. So it's probably no surprise to many of the people in this room that open source software is this amazingly important area of software development that's happening with the growth of open programming, of collaborative programming, where communities are maintaining these software packages for a variety of purposes. And these are just as important to small-scale scientific endeavors as they are to massive projects that are essential parts of our digital infrastructure. And so with that, there's some, the beauty of open source software is that there's everybody who's able to maintain this, work together, but as a result, there's a lot of volunteers that are pivotal to making this happen. And so what we see is that this volunteer-only community it could be incredibly fragile. That with the loss of a few members, some of these important pipeline projects could completely dissolve because of the lack of ability to maintain that critical mass. And at the same time, there's an increasing understanding that some of these communities have these toxic dynamics that don't lead to improved community health over time. And these two kinds of important aspects of open source software are kind of captured beautifully in this really kind of striking example of Guido von Rossum, who is the former benevolent dictator for life, or BDFL, for Python. And again, he was the benevolent dictator for life, but after a particularly contentious Python release, he stepped down from that position and refused to name a successor. And given that he acknowledged that it was that contention in the community that caused him to step down in that way. And when we look not just at something as big as Python, but at a number of important open source projects, if we look at the percentage of commits or contributions of code that are contributed by a certain number of contributors, if we plot that relation, what we see is that for 8 really important open source projects, the majority of the code is being maintained by fewer than 10 people, some fewer than 5, which means, as they like to say, the bus factor, or the number of people that would have to get hit by a bus before your program is unusable, is incredibly small. And as a result, that incredible sensitivity to loss means that it's critical for them to be able to recruit and retain new contributors to have this vibrant community that we all depend upon. So when we're thinking about why we might, what we might expect to find in looking at these digital traces, one of the things that I think is most compelling about naturally occurring data is looking to theories and previous work in other domains that can provide expectations that we can investigate and validate in these naturally occurring data. So when we look to ethnography and psychology, they tell us a few things about how communities, especially communities of volunteers, might be driven to communicate with one another and how that might connect to their long-term health prospects. So one thing that ethnographers who studied GitHub have shown is that GitHub as a platform, because of its social dynamics, has what they call social translucence, which is where you, as part of this open community, are opening yourself up to potential judgment, which is kind of stressful for people. But at the same time, there's this consciousness that you need to acknowledge people who are contributing for the good of the community. So you've got this negative downward pressure of the potential judgment, but also this positive pressure that you should be encouraging others. And when we think about how newcomers engage, whether newcomers come in and really throw themselves into the work or become turned off to the process of volunteering, we need to look to the motivation for why people volunteer in these communities and just generally volunteer on projects at all. And one of the things that's particularly important for people who are engaged in open source software is this idea that this is an opportunity for people to learn and have new skills that they find valuable by engaging with more expert programmers. And for both the general sentiment of communicating with others and for the importance of newcomer retention, feeling emotionally supported is critical. Feeling like you are appreciated, feeling like you have a positivity and a joy to go to work on this volunteer project, that you have a full-time job, potentially you're a full-time student, and still you spend time on this project. So this is linked to better problem solving, more motivation, continued engagement with critical problems. So taken together, we see that there are some affective and communication dynamics that could suggest certain patterns that might be more indicative of a healthier community and understanding what that means for the real world outcomes for these projects. So what we wanted to do is we wanted to kind of answer 2 questions. We wanted to look at how, from the field of psychology, we could understand better the community dynamics in this real world community, but also do that in a setting that could give back to important things that we as scientists and as a society really rely on. So our two research questions with this was first, how do open source software communities, or OSS, communities communicate? What we want to understand is how do we see how people are talking to each other emotionally, and how are they expressing their gratitude in a way that we think from previous work should be really important to understanding those dynamics. And when we understand how those communities are communicating, what does that tell us about the ability to retain new members, new potential contributors to the project? So what we want to do is we want to be able to take what we learned from the first set of analyses and apply that into repercussions that could give us information about how these communities could better interact. So if you're not familiar with GitHub, because we're going to be working with GitHub data, I want to give you a very brief introduction to the kinds of data that are available on GitHub, so you can kind of have that in your mind as we're moving through. So when collaborative code development unfolds on GitHub, there are two primary ways that people could contribute to a project. They could contribute issues, which are ways of flagging a bug or requesting a feature on a project. Along with that, you have what are called pull requests. We'll also refer to those as PRs. Pull requests are contributions of code that offer, for example, bug fixes or a new feature that could be suggested by them. So in one, you're flagging problems, in the other, you're contributing something to the community. And to give you kind of an insight into what those data might look like in a toy example, you have what a user who is contributing in natural language, some kind of description of the issue or code. You have then this threaded ability for communication where people are able to talk with one another in natural language about the problem. And at the end, you have some kind of outcome that is associated with closing the issue, addressing the issue, or integrating that suggested piece of code into the code base. So this is really nice from an analysis standpoint because we have, across these two different kinds of contributions, parallel structures, which means that we have identical data from these two different sources. The difference between them is the communication context, the goals of that communication. People are either flagging something that's wrong or contributing something that is a novel contribution to that. So to collect the data, what we did is we selected 8 open source software communities that vary in terms of size of the regular membership, contributors from that, and they're all considered really important projects to scientific Python. So, and all of them primarily develop on GitHub as well. So using the GitHub API, we were able to get information from posts. So these are the pull requests and issues that we mentioned before, and then the replies to those. And these are the threaded conversation that happens after someone posts an issue or pull request. So this is kind of an example of the data that we can get from that, where we have here's the post here. We have the person that is posting it, the timestamp, the person's standing in the community, the text of their conversation, or their comment, whatever they're putting out there for the community, and then here is an example of the thread that would come after that. So again, you have the people who are replying to it, their identity, and the content in natural language of what they're saying about it. So from both of these, from both the posts and the replies, we can pull out some dynamics of language use, identified from previous expectation from ethnography and psychology literatures. So we can pull sentiment. So with this, we have for each post or reply, for each activity item, we have a score from -1 to +1 that is rated in terms of the overall emotion that these people are using, and they're using Vader sentiment, which is a sentiment analysis tool that's particularly well suited to online data because it takes into account things like emojis and capitalization and punctuation that really does convey a lot when people are communicating online. And then for gratitude, we simply identified a number of different unigrams that express gratitude, looking at what the community, how the community expresses thanks and things like that. And so we took a log of the count of unigrams for gratitude. So for community metrics, we were able to pull out user standing. And although GitHub presents some information about who the users are relative to the rest of the community, we thought a more dynamic measure would be better. So what we did is we dynamically measured this as a member of the community being someone who had contributed five posts or more to that community. And so every time they made a post, we recalculated whether that person was a member or a non-member at the time. Someone who had given 5 contributions to the community was a member. Until then, they were considered a non-member. And then we also calculated responsiveness of the community to the issue or pull request. So this was how quickly that post was resolved, how quickly the issue was addressed adequately, or the pull request was integrated into the code base. So for this, the scale of data is much larger than a lot of people dealing with kind of communities in the real world and ethnographers deal with, but the data aren't as massive as the data that some people have been presenting here. But we have these 8 unique projects that give us a window into this kind of community. We have about 20,000 unique users, about 69,000 unique posts, and about 437,000 unique replies. So from a naturalistic context, we've got this rich window into how these communities are unfolding. So we did a few different models that I'll walk you through kind of a high level. So when we look at how people are responding in terms of emotion, looking at how people are responding positively or negatively to the community, what we see is that when predicting sentiment with activity type, so it's a post or an issue or a comment, a post of a pull request or an issue, or a reply on a post or an issue or a pull request, and community membership, whether they're a member or a non-member, and the interaction of those two. What we find is that people are generally more positive when they are responding to other people. And so no matter what kind of a reply someone is doing, whether it's in here you have the replies in the lighter color corresponding to that contribution type, where an issue is this kind of orangey color, and a pull request is this purpley color. So here you have members on the left and non-members on the right, with sentiment on the y-axis. So we see that generally for members and non-members, for issues and pull requests, whether you're flagging a problem or providing a solution, you see higher positive sentiment. But we see that people who are replying to pull requests, people who are replying to these new contributions, they're significantly more positive than people who are replying to this problem that people are flagging. But we do see some modulation by your standing in the community, where outsiders are showing more positivity than members in other contexts. So overall, there's no difference in emotion between how these communities are responding to each other based on membership or non-membership, but we do see that there are certain times at which non-members are expressing more positive emotion. When they, for example, are presenting a new piece of code for people to incorporate into the code base, or when they're replying to problems that other people have solved. So this is particularly interesting that because of the expectations and the anecdotal evidence about how negative the open source software community can be, that we see that there is still, in some cases, that these non-members who have no stake in the community are still as positive in many regards as the members are. And the members typically are the ones who get the bad rap in terms of how positive or not positive they are to one another. So the next model is identical, except that we were predicting the log count of gratitude expressions with the same predictors. So again, here we're going to have gratitude on the y-axis, and what you're going to notice first is that people rarely express gratitude explicitly to one another. So about 89% of all activities don't have any expression of gratitude. But when we do look at these models and try to understand in what contexts those emerge, we do see that outsiders show much more gratitude than members, especially when they're flagging problems that need to be solved by the community. So this is suggesting that perhaps what's happening is that these non-members are recognizing the time and effort that it's going to take to solve these issues, and so they're coming and being grateful at the time, trying to show their appreciation for the community. But interestingly, both members and non-members, when they are contributing new code, they both show gratitude at the same rates. So both of those together show that language is constraining, language is constrained by context and membership, your standing in the community, and the type of communication that you're trying to have with someone changes the way you use language. But also communities, we wanted to see not just how this works generally, but how do individual communities develop these different contexts that form these self-sustaining, more positive, or more negative, more grateful or less grateful dynamics. So when we look at this, what we find is that some communities show these unique patterns where they might be more strongly affected by the type of contribution that people are doing, whether you're coming with a problem or a solution, or whether your members or non-members are different. And so what we see if we're looking at emotions, so these are two projects that are that were in our data set, scikit image, which is a plotting library for Python, or an image analysis library for Python, and then NumPy is a numerical Python. And so these are both very important. We see sentiment here on the left-hand side of this plot. So we see that some communities have no difference in the membership or non-membership, including two of our smallest communities, which we want to kind of dive into and understand that a little bit better, because is that a reflection of just the pure size of the community, or are they more in touch with their smaller user base? And we see that gratitude, interestingly, overall shows stronger community-specific effects, that it seems like there are norms that happen with one community versus another, that they have different patterns of expressing emotion or gratitude to one another, including one community, interestingly, that shows more gratitude when people are flagging problems than when they're coming with solutions, which is an interesting dynamic. So we also see changes over time, which I don't have time to get into, but we also see these interesting time-dependent dynamics where they unfold in different ways. So next we wanted to take those two results that we had, the understanding how sentiment and community dynamics then will influence whether or not someone comes back. So what we wanted to do is we wanted to model the degree to which someone who posts a first post of some kind, an issue or a pull request, will come back and post a second time, will contribute again. So what we wanted to do is we wanted to incorporate a number of different models, a number of different predictors that we thought, based on understanding the literature and the previous results that we had, might play a role. So we predicted whether or not someone came back using the time that it took to close that response, the number of replies that people had, so how active the community was in discussing it, the average sentiment of the replies, the most negative reply, the amount of gratitude that people expressed, and the degree to which all of the members were more active than non-members of the community in responding to this. So this is a scatter plot. It's one of the main takeaways from this is just to kind of look at the number of people who are lost. There are a number of people who never come back to give a second post of any kind. But what we find is one of the strongest effect, the strongest effect, is what kind of contribution that newcomer provided. Newcomers who present a new piece of code are much more likely to come back than people who flag an issue. And we see that the community response to this newcomer is really important along a number of dimensions. So that newcomers are going to be more likely to come back when they have a faster action on that post, when it's resolved more quickly, when there's more conversation around it, and when there are more positive average emotion in that reply chain. But interestingly, we also see some interaction effects with the type of contribution, suggesting that there's modulation based on what kind of contribution they're giving. So welcoming means different things to different contributors, to different kinds of contributions. So we see, for example, here, if we look at newcomer attention, whether someone's retained or not, and looking at negative emotion, the maximum negative emotion expressed in the comment thread, what we find is that when people have more negativity in the pull request, when people are being more negative when people are contributing code, when their max comment is higher, they're much more likely to come back. Whereas if people have highly negative responses to an issue, they're much less likely to come back. And tying that in with the finding that that gratitude is also differently related to this, where people who are met with gratitude when they bring a pull request are more likely to come back, where people who are left with gratitude with issues are much less likely to come back. What we think this means is that this is a signal in this data about the goals that these people are having in coming to the communities. So as we mentioned before, previous work on ethnography has suggested that people join these communities because they want a learning experience. And so what we suspect is that this negativity is indicative of this kind of learning, this teaching, these teachable moments that the experts are having in suggesting changes to the code. But they're still doing that with gratitude. They're thanking someone and suggesting, well, that doesn't really work, why don't you try this? And kind of giving them guidance along the way. And that's supported by a follow-up analysis that we did that hadn't been planned, looking at the sentiment variance in the replies. And we find that sentiment variance is also differentially related, such that people with pull requests who have higher sentiment variance, more high highs, more low lows, at the same time are more likely to come back, but people with lower variance in the issue reply chains are much less likely to come back. So we think that this supports the previous work in ethnography and at this kind of larger scale. So tying it back to our original two questions, when we think about how these open source software communities communicate, we're delighted and pleased to see that people are actually having a good degree of positivity when responding to others, which is shown from previous research to be an important factor in having people continue in these volunteer roles. And it's especially true when people are offering new things rather than flagging problems for the community. But it seems like community members might be taking one another for granted by showing less gratitude, which is something that kind of rings true at an anecdotal way from people who contribute to these projects who feel often that they're underappreciated. And we also, excitingly, in terms of understanding the dynamics of these individual communities, show these individual effects over time and by different communities, so that we see these kind of microcosms emerge over time. When we think about newcomer retention, what we see is that overall newcomers are more likely to come back when the community is responsive to that contribution. And that contribution, that response, is tied up partially in that expectation from ethnography, showing that people are doing it for the value and the opportunity to them in that project.